Good evening, our listeners, and welcome to our today's class. Today, we are still looking at the aspects of elementary probabilities. And in one of our previous classes, we already had enough time to explain much about elementary probability, especially looking at set and set theories as they concern elementary probabilities. We equally looked at what we call a sample space and the event space. We equally looked at different kinds of events as it concerns what we call independent events, mutually exclusive events, what we call maybe equal likely events, and the rest of them. We equally looked at what we call random variables and properties of the random variables. Excuse me, let me remove something from the face of the camera. Yes. And then we equally looked at what we call the probability distribution function. Probability distribution function as it concerns the discrete random variable and the continuous random variable. We equally looked at what we call the expectation of a random variable. We equally looked at what we call the variance of random variable. And we took some examples in that lesson about expectation and the variance of random variable. Today we are going to be looking at the properties of expectations of random variable, the properties of variance of the expectation of random variables, and perhaps the standard random variables that we know, especially as it concerns the standard discrete random variable. So first of all, today we are going to look at the expectation of random variable, properties of expectation of random variable, look at the variance of random variable, properties of the variance of random variable. So today we are looking at what we call expectation of random variable. Expectation of random variable. R.V stands for random variable in this discussion. In our last class, when we treated expectation of random variable, we said that expectation of random variable is denoted with E of X. So when we write what E of what X, we are talking about expectation of random variable X, where this X stands for that random variable. When we write E of what? Y, we are talking about expectation of the random variable Y. And of course, in that class, we say that expectation of random variable X is expressed as that what E of what X is given as summation I is running from what I, or I is running from, or let me say expectation over the range of what X, of what X, P of what X, where this P of X equals X, or ordinary P of X. Let me be using what I used in our previous class, even though they mean the same thing. So let me be using what? P of X, where this P of X is talking about the probability mass function. And then this X is the value of these random variables. This thing is so when this random variable X is discrete. But when this random variable X becomes continuous, it will be expressed as that E of what X is given as integral over the range of X F of x dx, where this f of x is called the probability density function. It is a function that assigns a probability value to the values of a continuous random variable. Why this p of x is called the PMF, which is a function that assigns a probability value to the value of a discrete random variable. So today we are looking at the properties of the expectation of random variable, be it continuous or be it discrete. Properties of expectation of random variable. So permit me to clean this illustration which I did here. So we are talking about properties of expectation. So we are talking about what properties? Properties of E of what? X. Number one property. You say that what? E of what? A equals what? A. If and only if A equals constant. So what is being said in this property number one is that expectation of a constant is equals that constant. That's exactly what we are trying to say here. It implies, I will say therefore, E of what? 2 equals what? 2. In as much as this 2 is what? A constant. So expectation of a constant is what? A constant. Equally, E of what? 3 equals what? 3. In as much as this 3 is what? A constant. And of course, our E of what? B equals what? B, with the information that B is a constant. So expectation of a constant is a constant. That is what is said in this property number one. So in property number two, we are saying that expectation E of what? A x, where this A is a constant and this x is a random variable, is given as this equals what? A. This A comes out A of what? Of x. On the condition that this A is a constant and this x is a random variable. Therefore, if someone asks us to find the expected value of what? E of what? 3 what? X. This 3 stands as if to say is this A. So it comes outside and becomes what? 3 E of what? Of X. What if we have an idea that E of X is something like what? 3, or E of X is something like what? 2. You say given that E of X equals what? 2. We now say therefore our E of 3 what? X equals what? This 3 outside multiplied by E of X has been given to be 2, we so multiply by 2, and this thing becomes what? 6. This is property number 2. The expected value of a constant multiplied by a random variable equals the constant multiplied by expected value of the random variable. This is property number 2 in the discrete random variable, or in expectation of a random variable, whether it is discrete or whether it is continuous. That is property number 2 of expectation of a random variable. Permit me to clear here to continue with the property number 3. So let me clear here. Okay, property number 3 says, number 3, the expected value of what? A of X plus what? B is given as a e of x plus what b, on the condition that a and b are constants. Because if a and b are constant, this quantity can be expressed as e of ax plus e of what b. And if this a is a constant, based on property number 2, it will be expressed as a e of x. And then based on property number 1, that says that expected value of a constant is a constant, it becomes what? B. And that's what we have here. So on that ground, if someone tells us that we should evaluate, that is, we should evaluate that e of 2 what? X plus what? 3. We should evaluate this. Then he now tells us hint that e of what? X equals what? Let me say 1 over 2. First of all, we come here and express this as this. And it becomes that this equals what? 2 comes outside just like this a came outside. E of what? X plus what? This constant just like this b, it becomes 3. But we are told that e of x is 1 over 2. So in place of this e of x, I will put 1 over 2. So this becomes what? 2, which is outside, multiplied by 1 over what? 2 plus what? 3. This 1 over 2 is here and this 2 is here. This is 1 and this is 1. 1 times 1 is 1 plus 3. This becomes what? 4. So this thing becomes 4 when e of x is equals to what? 2. E of x could be anything. Okay? So these are some of the properties that we'll look at under the expectation of a random variable. So we are equally going to go over to what we call the variance of a random variable, look at how it is defined, and equally look at the property of the variance of a random variable before we go over to the standard discrete random variable. So permit me to clean here. So we now talk about the variance of a random variable. Variance of a random variable. Variance of a random variable. So when we talk about variance of a random, this RV stands for random variable, as I did say before. And in that our class, we say that the variance of a random variable is most likely denoted by, you write V of what? X. Or you write VAR of what? X. Where this X stands for random variable and V here stands for variance. Or AR here stands for variance and X here stands for what? For the random variable. And it is expressed as that var of what? X is given as what? E of x raised to power 2 minus E of x all raised to power what? 2. This is the expression of the variance of random variable, be it discrete or be it continuous. So when it becomes discrete, we are going to express what it is like. And when it is what? Continuous, we are going to express it just the way it should be. So when this random variable x is discrete, this variance will be expressed as this. That V of x is given as, here becomes summation over the range of x. What we have here is x raised to power 2. So I will equally write x raised to power 2 p of x. The sign here is minus, I'll have minus. Then what I have inside this bracket is E of x. And of course, E of x is expressed as what? Summation over the range of x. What I have here is what? X. P of what? X. I'll close the brackets. But then these brackets are all squared. So I'll say something like this, and I'll say raised to power what? 2. So this is how it is expressed if we are discussing discrete random variable. But if this random variable x becomes continuous, it will be expressed this way, that my v of what? X is given as, in place of this is going to be integral over the range of x. Here is what? X raised to power 2 f of x dx, in place of this one, minus. I'll come here, what I have inside the bracket is integral over the range of x. Here is what? X. F of what? X dx. This thing is put in the bracket. I will now open and I will now what? Close, all raised to power what? 2. This is how it will be expressed if this random variable x is a continuous random variable. So we are equally going to look at the properties of the variance of a random variable. Do remember that in one of our previous classes when we discussed the expected value and the variance of random variables, we already had looked at some illustrative examples. So situation whereby you are finding it difficult on how these equations can be evaluated given a specific random variable or a defined random variable. We recommend that you visit one of our previous classes when we talked about at a continuation of elementary probability. If you go there, you see a lot of examples that are drawn from various areas and then trashed or solved about expectation and the variance of a random variable. So we're equally going to look at what we call the properties of the variance of a random variable. So permit me to clean here. So we talk about what we call properties. Properties of V of x. What we mean by V of x here is variance of a random variable. We say number one, that V of A equals 0 if and only if A equals constant. That is to say that variance of a constant is 0. So variance of 1 is 0, variance of 2 is 0, variance of 0 is 0, variance of 10 is 0, because 0, 1, 2, 10, and the rest of them are all constant. Variance of A is 0 if A is said to be a constant. Variance of B is 0 if B is said to be a constant. But that letters must be defined before you can get to know exactly or completely that they stand for constants. Because oftentimes some letters of the letters of alphabet are used as constants and equally used as variables. So it depends on the definitions. Okay, so we have therefore. We say therefore V of what? 1 equals 0. V of what? 2 equals 0. V of A equals 0. V of B equals 0. When A and B are regarded to be what? To be 0. So we now move over to the next one. So property number 2. That number 2 I say var of what? A x is given as A raised to power 2 var of what? Of x. That is to say that variance of a constant multiplied by a variable is that constant square multiplied by the variance of that random variable. Variance of a constant multiplying the variable being equal to constant raised to power 2 multiplied by that variable. So in that case, we can say therefore that var of what? 2x is given as what? 2 raised to power 2 var of x. What if we were told that var of x is either 1 over 2 or var of x is equal to 1 over 3? It means we can evaluate this when they give us that information. So this, of course, is the number 2 property of the variance of a random variable. Okay, you permit me, or first of all, let me write number 3 here before I clean the board. Okay, we equally have that var of what? Ax plus what? B equals var of what? Ax plus var of what? B, on the condition that this A and B are constants. Because if this A is not a constant but a variable, and this B is not a constant but a variable, it cannot be expressed like this. The expression is going to connote or involve what we call the covariance term. But it can only be expressed like this if A and B are constants. And in this case, we are going to express this one like this. And this becomes A raised to power 2 var of x plus. Do remember that variance of a constant is 0. And this B is a constant, so it becomes 0. And this thing becomes what? A raised to power 2 var of what? X. Therefore, var of what? A constant multiplied by a variable is the same thing as var of a constant multiplied by a variable plus a constant. Both of them will return the same values. So if you ask anybody, permit me to clean here. So if you ask anybody to look for the value of what? var of what? 2 what? X plus what? 3. They will now say where var of x equals 1 over 2. Something of this kind. Then they will tell you and. Of course, you know there's no need for and, because you know that 2 and 3 are constants. So they don't need additional information to get to know them as constants. So what we are going to do is to express them in this format. That this becomes 2 raised to power 2 var of x. Plus what? Here becomes what? var of what? Of 3. And then 2 raised to power 2 is 4 multiplied by var of what? Of x. Then plus what? 0, because variance of a constant is what? Is 0. So this thing becomes 4 multiplied by var of a constant is given as what? 1 over what? 2. So 2 here is 1 and 2 here is what? 2. So this becomes what? 2. So these are some of the properties of the variance of a random variable, which of course anybody can be asked to manipulate some questions around it. And the moment you can recall these properties of random variable, obviously you'll be able to find or jungle your way out of the problem successfully. So thank you very much for your audience. Thank you very much for following us in our various classes. We do appreciate your audience and your time, and we still keep to continue to plead with you that if our classes in any way or form is adding value to your life or to the life of people around you, that you help us to follow us in our various social media platforms, subscribe to our YouTube channel, like, share, comment on our YouTube videos, so that our classes will keep to reach greater number of persons. These are properties of expectations, properties of variance of random variables. Then let us now go into what we call standard random variables. Standard random variables. Permit me to clean here. Of course, in our previous class, we already had a defined random variable in connection to elementary probability. Because random variable seems to have a little diverse definitions as it concerns some aspect of statistics or mathematics. Here, when you are talking about random variable, here you are talking about a function that assigns real numbers to the outcomes of the random variables or to the outcomes of a random experiment, which is the same thing like saying a function that assigns real numbers to the outcomes of a sample space or to the members of a sample space. However, when you want to define random variable in another aspect in statistics, you can still see that random variables are those characteristics that can assume different values across the units of the population. So random variable keeps to change its definition and meaning gradually over different concepts in mathematics and statistics. So, but in the concept of what we are discussing here, we are seeing random variable as a function that assigns real numbers or what we call real valued function to the sample space. But here we are talking about standard random variables. There are variables or random variables that their properties and behaviors are known and established. And we call such random variable standard random variable. And of course, you know that these random variables are classified into two categorically as discrete random variable and continuous random variable, depending on the nature of their range space. That if the range space of a random variable contains discrete units or discrete numbers, we describe that to be a discrete random variable. But if the range space contains an interval of observations, we describe that as continuous random variable. So we are going to look at standard random variables now under discrete random variables. Under discrete random variables. Discrete random variable. Some of these random variables we'll be looking at that are standard known. When we talk about their being known, we talk about knowing their properties. And when we talk about knowing their properties, we are paying attention to knowing the values of their means, their variances, and then their moment generating functions, MGF. So number one, we are talking about what we call the Bernoulli random variable. Bernoulli random variable. Number two, we are going to talk about what we call the binomial random variable. Number three, we are going to talk about what we call the Poisson random variable. Number four, we are going to talk about what we call discrete uniform distribution. Discrete uniform distribution. Discrete uniform distribution. Then, of course, we are equally going to look at what we call the geometric distribution or random variable. Do not get so lost when we talk about Bernoulli random variable and Bernoulli distribution. There are definitions. Of course, when we talk about Bernoulli random variable, we are talking about either X or Y that follows a particular distribution that can be identified as what as Bernoulli. So oftentimes, these two statements can be used interchangeably. Though we know what is called distribution and we know what we call the random variable. Okay? So we are going to start with the Bernoulli and be discussing them one after the other. Of course, when we talk about geometric, we are going to look about the geometric of the first kind and geometric of the second kind. First of all, we are going to start with a Bernoulli random variable. Okay, so let me clean this one. So bear these ones in mind. Clean this one. Yes, Bernoulli random variable. Okay, a random variable x is said to follow a Bernoulli distribution or a Bernoulli trial if and only if that random variable x can assume only two possible outcomes. Only two possible outcomes. Then we now say that that random variable x follows a Bernoulli distribution or a Bernoulli trial. These two possible outcomes could be either be success or failure, yes or no, defective or non-defective, and the rest of them. We now say that such a random variable x follows a binomial distribution. Sorry, a Bernoulli distribution. And of course, because it is a discrete random variable, then the distribution function, or what we call the probability distribution function of this Bernoulli distribution is going to be what we call PMF, probability mass function, a distribution that assigns a probability value to all the outcomes of a Bernoulli random trial or variable. And of course, that PMF of a Bernoulli distribution is given as P of what? X equals X is given as P Q 1 minus X when X equals 0, 1. Okay? So a random variable equal X is said to follow a Bernoulli trial or a Bernoulli random variable if and only if the PMF of that random variable S can be written as this, where P is the probability of success, Q is the probability of failure, and then this random variable X can only take two possible numbers, 0 and 1. So wherever place we see a thing like this, of course we know that that random variable X is said to follow a Bernoulli distribution. What are the properties of this Bernoulli distribution? So anybody can ask you, what this is what from this x equals 0 and 1 is what we call the range of the Bernoulli random variable or the Bernoulli distribution. So anybody can ask you, the range of a Bernoulli distribution is what? Or ranges from what to what? The answer is from 0 to 1 because it can only take two possible outcomes. Yes or no, defective or non-defective, and the rest of them. Blind or non-blind, dead or alive, and the rest of them. Then, of course, I already had said that P is that of success, and then Q is that of what? Of failure. So what is now the mean, which we call the expected value of a random variable that follows Bernoulli? We now say that the expected value or expectation of Bernoulli random variable, which of course will be written as E of x, is given as what? P. So the expected value of a random variable x that follows a Bernoulli is the same thing as the probability of success. So number 2, we talk about the variance. Talk about the variance of Bernoulli random variable. When you talk about the variance, we are going to say V of x is given as what? P Q. Which means that the variance of a random variable equals the product of the probabilities of a success and failure. These values must be noted in case somebody says, if the probability of success in a Bernoulli trial is 0.3, find the expected value of that Bernoulli random variable and then the variance of that Bernoulli random variable. The moment you record this and this, you'll be able to get the answer. And of course, do remember that there is a condition between this P and Q. We say where P plus Q equals 1. So when they give you the probability of success of that trial in the Bernoulli random variable to be a particular number, you can easily find the probability of what failure and be able to answer these questions. So for now, these are much I expect you to know about the Bernoulli random variable. In our subsequent classes that will be coming up, we should be looking at deeper problems that concern more with people who want to dig deep into statistics. We should equally be looking at what we call the MGF, moment generative function, and possibly the characteristic function of this random variable. But for now, this is what I want you to know about Bernoulli random variable. So permit me to clean here. Do remember, this is the PMF is given as this, probability mass function, expected value this, variance that. So we talk about the next discrete random, standard random variable, which we wrote here is binomial random variable. Binomial random variable. We usually say that a random variable x is said to be what? To follow a binomial distribution. If that random variable x follows Bernoulli distribution, but that a trial is repeated over time, say up to n times. So when a Bernoulli trial or random variable is repeated over time more than once, we say that that random variable follows a binomial distribution. And of course, we know that this binomial distribution has got its own PMF, probability mass function. That is the function that will be assigning the probability value to the range space of this binomial random variable. And of course, the PMF of a binomial random variable is equally given as that P capital X equals small what? X is given as n combination X, P of X, Q of n minus what? X. Where this X takes a value 0, 1, 2, up to what? N. Because you are repeating that Bernoulli trial, say, up to n times. So this is, of course, what we call the PMF of a binomial distribution, or this is a binomial distribution, and of course, it is the distribution of a binomial random variable x. Okay? So the next thing that they ask you, what is the range space of a binomial random variable? The range space ranges from 0 to what? To n, where n is the number of trials. Okay? P, of course, stands for what? The probability of success. Q, probability of what? Failure. N, number of trials. Okay? So, the question there is, what becomes what we call the expected value and then the variance of a binomial random variables? So, we now say number 1, that E of X here becomes what? N, P. In the Bernoulli, it was just what? P. But this time around, we are saying that Bernoulli has been repeated up to say n times. So you are now talking about the product of that repetition multiplied by the probability of success, n, P. So this thing becomes what? The expected value. And then the variance now becomes number 2, that variance var of x is given as what? N, P, Q. In the Bernoulli, it was just given as what? As PQ. So this time around now, it is given as the product of what? The number of trials, then the P, and then the what? The Q. So somebody can say, if a random variable x that has two possible outcomes, or that can assume two possible outcomes, is repeated up to 5 times, if the probability of success, which could be getting of what? Of the head or getting of tail, depending on what they define to be what success, is 1/2. What is the expected value of that random variable, and what is the variance of that random variable? This n says it is repeated over up to 5 times. P here, which is the probability of success of getting either head or tail, depending on what they are saying is the success in their own experiment, is 1/2. So it becomes 5 times 1/2. And then here now, the variance becomes what? 5 times what? 1/2 times what? 1/2, which becomes what? The variance. So that is now what we call the distribution of a random variable x that follows a binomial distribution or binomial random variable. The thing there is, how do we formulate questions about this? How do we formulate questions about this? We can formulate a question about this by saying, of course, permit me to clean this variance and this here, and equally clean this. Now, the toss of a coin in the A, I just want to give illustration on how questions can come from this particular distribution. Of course, the toss of a coin in the A has two possible outcomes. It either comes with head or it comes with what? Tail. So that random variable x, which is the trial of the toss of a coin in the A, can only assume two possible outcomes, the head or the tail, which oftentimes is denoted with what? 0 for tail and 1 for what? For head. Now, what if now somebody now tosses this coin into the A up to 5 times or up to 6 times? And then we are talking about a random variable x that counts the number of what? The head, which is the success the person is going to record in that trial. Then, number one, it is understood that the toss of a single coin in the A is a Bernoulli. It has 0 and 1. When it is repeated over time, up to 6 times, as I mentioned now, it ceases from being Bernoulli and becomes binomial because it has been repeated over time. And we are talking about a random variable x that counts the number of what? Of heads. Do know that it is possible that the person throws up to 5 times and didn't get a head. So in that case now, the number of heads becomes what? 0, comma. It's equally possible that the person throws up to 6 times and happens to get what? 1 head. It becomes 1, comma. It's possible he throws 6 times and gets 2 heads. It becomes what? 2. And then this thing continues now, continues to 4, continues to 5, continues to 6. It's also possible that he throws 6 times and happens to get 6 heads. So this thing becomes what we call the range space of this kind of experiments that I have just described. So what we do is, we now come back here now and write the PMF of a Bernoulli distribution now and talk about solving this problem. So in this case now, we are talking about that my n is equal to what? 6, because that thing was repeated up to 6 times. And then, of course, this thing becomes my what? My x. My x that counts the number of heads. Number of heads could be 0. I didn't get in 1. It could be 1. I got 1. It could be 2. I got 2. Down to 6. It could be that I got 6. So I will now come here and say probability of capital X equals small x is given as what? N combination what? X. P of x. Q of n minus what? X. What if they give us an additional information that the probability of getting what? Head is 1/2 in each of the trial? So I have that my P equals what? 1/2 as an additional information. So which means if I come here, I will now say that x equals to 0, comma 1, comma 2, up to what? Up to 6. And of course, therefore, my n equals what? 6, and then my p given to me is 1/2. So I will now clean this information because I've transferred them here. So somebody will now ask you now, what is the probability that after this throwing of a coins up to 6 times, that the person gets no head? If the person gets no head, it means the person has gotten 0 head. And if the person has gotten 0 head, you are saying the probability that this random variable x takes a value 0. So in that case, you are going to say P of this capital what? X equals what? 0 is given as. Here is my n, and my n is what? 6. 6 combination 0. My P is given as what? 1/2 here. So you now say 1/2, open and close. Raised to power what? 0. Open again. If P is 1/2, my Q is going to be 1/2 because P plus Q is 1. So which means say I have 1/2 all raised to power. Here is what? 6 minus 0. So this thing becomes what? 6 combination 0 into 1/2 raised to power 0 into 1/2 all raised to power what? 6. And with your calculator, the moment you evaluate this, you must have gotten the probability that x is equals to 0. The same thing applies when they say x is equals to 1. You replace this 0 with what? 1. And anywhere you see x here now, it takes the value of what? Of 1 down to 6. The only thing they will ask you here, which I want to explain, is when they say, what is the probability that x is less than 2? X is less than what? 2. So you are talking about probability P that x is less than what? 2. Of course, if x is less than 2, x can become what? 0. X can become what? 1. So what will satisfy this thing I wrote here is saying that this equals to probability that x equals 0 plus probability that x equals to 1. That is what satisfies this condition. So you are going to evaluate the probability when this x is equals to 0 and evaluate the probability when this x is equals to 1. Add both of them together and you must have answered this question. Okay? What if now they say probability that x is greater than what? 2. So I have P that x is greater than what? 2. If x is greater than 2, it means that x is going to be 3, 4, down to what? To 6. And it is going to be difficult for us, or a little bit demanding, to go and look for. So what satisfies this is now that probability that x is equal to 3 plus probability that x is equal to what? 4 plus probability that x is equal to what? 5 plus probability that x is equal to 6. This is what is going to satisfy this thing. And it's going to be a little bit demanding or time wasting, that we are going to first of all compute the probability that x is equal to 3, compute x is equal to 4, 5, and then 6 before we begin to sum them. The only thing we should bear in mind that the probability that ranges from what? 0 to what? 6 is equal to what? 1. And this one is talking about what? From 3 down to 6. Therefore, if I can come to 1 and remove the probability of what? Of a 0, 1, and 2, I must have gotten this. So this is the same thing as saying that this is 1 minus probability that x is less than or equal to what? 2. Because this thing began from what? 3. So in that case, what I'm just going to do now, then this thing becomes now that this equals 1 minus a probability here. I'll open a bracket like this and say probability now that x is equal to 0 plus probability that x is equal to what? 1 plus probability that x is equal to what? 2. I will close it. So the moment I find this probability, find this and find this, subtract from 1, I must have been able to get this probability. You understand? So this is actually how to go about looking for problems like this. What if they ask us another question? That question is, Let me clean this one first. What if they ask us a question that probability that we have what 5, then or we have what 4 less than or equal to x less than or equal to 6. That is probably that x is greater than or equal to 4, but less than or equal to 6. So we are going to start from 4 and end at what 6. So this is going to be probability that x equals to 4 plus probability that x equals to 5 plus probability that x is equals to 6. So when we evaluate probability that x is equals to 4 plus probability that x is equals to 5 plus probability that x equals to 6, we must have arrived at the what? At the answer. So, but then when they say that probability that what 4 less than what x less than what 6. So this one is what we say x greater than or equal to 4 or x is between 4 and 6 inclusive. Or this one is x between 4 and 6 exclusive. You are not going to count this for here. So it's going to start from, in fact, this thing that is written here on the board now is probably that x is what is 5. Because if x is going to be greater than 4 and x is going to be less than 6. And the only number that is in between greater than 4 and less than 6 is what? Is 5. So here is something I say probability that x is equals to 5. You see how this question could be. So they can give you something of this kind and they expect you to know that it is a probability that x is equals to 5. And in that case, you are going to say this is equals to, you know that n is 6 here, you say 6 combination. Here your x is what? 5 combination. 5, 1 over 2 in place of this p raised to power what? 5, open a bracket, 1 over 2 raised to power, n here is what? 6 minus what? 5. And the moment you use your calculator and evaluate this, you must have answered this particular question. So this is what we call the binomial random variable. Okay? Thank you very much. We still want to believe that you understood everything we said about the binomial random variable. If you're having a challenge about the binomial random variable, of course, you can drop your confusion or drop your comments in the comment sections. So once we come across it, we'll be able to come to your aid and then the rest of them. You can equally go and look at a scenario where we have a manufactured product and then someone is saying that the probability of a defective item is 1 over 2. Then the person say, out of 8 items that are taken from that place, find the probability that there is no defective item, there is 2 defective items, there is 4 defective items, there is greater than 1 defective item. It is the same question which we have solved on the board now. So you can try looking at questions that is tending towards that direction. Thank you very much. So we are going to go over to the next standard discrete random variable which we gave. And of course, what we gave that time was a Poisson random variable. So permit me to clean this one.